Hey guys, welcome back to the channel. Thank you guys for joining. I hope that you get a lot of value from this video. I'm actually creating this one for my day school students, but I did recognize that I could provide much value to everyone else who may come in contact with this channel. No, this is for the CXC students. This one is for those persons who know nothing about fractions, but you have to do mathematics. All right, so whether you fall on the category 1 or 2, this is a perfect video for you. Let's go. These are our objectives, and of course I'll be breaking this video into various parts so you can check the playlist just to figure out which parts that you're interested in. The parts that you've mastered, you can just skip over those. All right, so for the first video, we're going to be looking at what is a fraction, parts of a fraction, types of fraction, and equivalent fractions. Then video 2 will be broken up into changing from mixed number to improper fraction and changing from improper fraction to mixed number. Video 3 will be about adding and subtracting fractions with like and unlike denominators. Video 4 will be about multiplying and dividing fractions. And video 5, we're going to put all of it together to evaluate complex fractions using past paper questions. All right, so let's begin. First thing you want to ask yourself, what is a fraction? A fraction, as you know, is a part of a whole or number of items. Now, this fraction, as you can see below, which is 1 out of 8 or 1/8, was created by counting the number of pizza slices, that's our denominator, and then the value of interest, which is the number of slices beaten, would have been 1. So your bottom number or your denominator is always the total number of parts that the item or the object has been divided into, and the top number is the value being considered. All right, let's look over to our right where we have a group of students. Now the question was, what fraction of these students are girls? Now we're looking at the picture. The first thing we have to do is count the number of students. We have 1, 2, 3, 4, 5, 6, and 7 students in total, which makes our denominator or our bottom number 7. Then our value being considered, or the value of interest, is going to be the total number of girls. So we have 1, 2, and 3. All right, which makes our numerator or our top number 3. This line in the middle is going to be our fraction bar or vinculum, and what it does, it separates the top number from the bottom number. And yes, it is as simple as that. All right, so it gets a little more complicated as we go along, but the basics of fraction is that we have a numerator and we have a denominator. The numerator, or the top number, represents the number of parts of a whole that are being considered. The denominator, and also known as the bottom number, the number at the bottom, represents the total number of equal parts into which the whole has been divided. All right, and the vinculum or fraction bar is the line that separates the top number from the bottom number. And in terms of operation, the vinculum usually means to divide. All right, so in terms of operation, the vinculum represents division, and that might be useful for you in the future when you move over to even algebra. All right, so let's look at types of fractions. We have 3 main types of fractions that you will encounter. We have the proper fraction. That's when the top number is smaller than the bottom number. In other words, the parts being considered is less than the total number of parts. And in this circle, you can see the circle has been divided into 6 parts, which is represented by our denominator or our bottom number. And the top number is our numerator, which is 5, and those are the values being considered. In this case, it is the shaded areas. So we have 1, 2, 3, 4, and 5 shaded areas. However, overall, we have 6 number of parts. All right, let's move over to the second type of fractions, which is our improper fraction. And this is when the total number of parts being considered, or our numerator, is greater than or equal to the total number of parts, which is the denominator. Now, as you can see here, for each of the circles, we have 6 parts. So circle 1, all the parts are being considered, which is going to be 6 out of 6. For circle 2, only 2 parts are being considered, which are the shaded areas, and that would be 2 out of 6. So we have 6 out of 6 plus 2 out of 6, and that gives us our improper fraction, which is 8 out of 6. An easy way to remember improper fraction is that these are top heavy. The top is bigger than the bottom. Lastly, we have the mixed fraction, and that's when we have the whole number and also a proper fraction. And please look carefully, guys. The improper fraction and the mixed number, if you look at the diagrams presented, are exactly the same. It's only a different representation. The improper fraction does not consider a whole number component. It puts all the parts together and then reuse the total number of parts, which is the denominator. However, the mixed number clearly separates the whole number component, which would have been the complete shaded area, still 6 out of 6, which is 1. 6 into 6 goes 1 time. All right, so we have 1, which would represent 1 whole part, and then we have the proper fraction, which represents 2 out of 6. So it's not whole, it's just representing a portion. All right, so as we go forward, you'll see how improper fractions can change to mixed number in terms of representation, and mixed numbers can change to improper fraction as well in terms of representation, since they are the same value, just represented differently. All right, so let's move over to the last part for section 1, which is going to be equivalent fractions. And apology for the messy screen, because I've done this so many times and it keeps glitching, so I have to do it over and over again. All right, so let's look at what equivalent fractions are. So equivalent fractions have the same value but are represented differently. So same value, just look different. In the first diagram here, we have 1 out of 2. So we have 1 shaded area out of 2 parts. So that would give us a half, or 1 out of 2. For the second picture, as you can see, the same side has been shaded at the same size as well. The only difference is we have divided the circle into more parts, which changes the value of our denominator from 2 to 4. So we have 1, 2, 3, 4 parts, and it has split the 1 into 2 parts, which makes our numerator 2 instead of 1. So the same size, same part shaded, except we have divided the circle into more parts. Let's move over to our last fraction, which is going to be 4 out of 8. Again, the same area has been shaded at the same size. The only difference is we have divided the circle into more parts, or more equal parts. So instead of having 2 parts or 4 parts, now we have 8 parts, and we have shaded 4 out of that 8 parts. All right, so the most important part to recognize here for equivalent fractions, which will be useful when you move over into adding and subtracting fractions, is that they can be created very easily by multiplying or dividing the top number and the bottom number by the same value. All right, let's look at an example. Instead of splitting up the circle into 4 parts, we could have multiplied a half by 2 in the numerator and by 2 in the denominator, which would give us 2 out of 4. Yes, also we could have multiplied 2 over 4, the top number, by 2, and the bottom number by 2, which would have given us 4 out of 8. All right, and if we had split half once and then we fold the paper again, or we fold the paper again, we could multiply a half by the top number by 4 and the bottom number by 4, which would give us 4 out of 8. All right, and that is it. Also, in the reverse, we could divide 2 over 4 by 2 in the top number and the bottom number, which would bring us back to a half. Or we could divide 4 out of 8 by 2 in the top number and 2 in the bottom number, which would bring us back to 2 out of 4. So whenever you have a fraction that can be further divided, if it's not in the simplest form, for example 1 over 2, you can go ahead, once you can find a common factor between the top number and the bottom number, you can divide both by the same factor. Also, if you want to create a new fraction, you can multiply the top number or the bottom number by the same value, and that will give you an equivalent fraction, equal in value, only different in representation. All right, so that's it for part 1. Come back for part 2, and I hope you guys would have learned.